Hello, today we're going to be learning all about chemical bonds. These are the glue that holds atoms together in molecules. We're going to look at two types of bond today, ionic bonding and covalent bonding. First, let's look at ionic bonds. In ionic bonding, one or more electrons are transferred from one atom to another, so that all the atoms end up with a full outer shell of electrons. Think of it like this. It's lunchtime at school today, and Simon is sitting next to Claire. He notices that Claire has forgotten her lunch money today, and so he gives her a slice of his pizza. This is how it works with ionic bonding. Atoms that have only one or two electrons in their outer shell want to lose these, so they are left with a full outer shell. And atoms that have nearly full outer shells already want to gain electrons to make their shell complete. And so electrons are passed from one atom to another, so that they both have complete outer shells, giving them the same electronic structure as a noble gas, like helium. After transferring electrons, the atoms have now become ions. The atom that lost an electron becomes positively charged, and the atom that gains an electron becomes negatively charged. Due to their opposite charges, these ions become attracted to each other by a strong electrostatic force. This is the ionic bond. Now, let's see an example. Sodium reacts with chlorine to form sodium chloride, or as we know it, salt. Sodium has one electron in its outer shell. It gives this electron to chlorine and becomes a positively charged ion. Due to this extra electron, chlorine has now become a negatively charged ion. These ions are now attracted to each other, forming sodium chloride, which is an example of a giant ionic lattice, which looks like this. Within this lattice, the electrostatic forces are acting in all directions, holding it together. For your exam, you need to be able to draw the ions in certain ionic compounds. But don't worry, this is really easy. All you need to do is take the atom after the electrons have transferred and put big square brackets around it. Then you should add a plus or minus sign to show the ion's charge. Remember, the atom that lost the electron becomes positive, and the atom that gained the electron becomes negative. Sometimes atoms may lose or gain more than one electron. For example, elements in group 2 of the periodic table have 2 electrons in their outer shell, meaning they will need to lose both of these electrons to achieve a full outer shell, and so they become 2+ ions. For example, when magnesium bonds with oxygen to form magnesium oxide, magnesium loses 2 electrons, becoming a 2+ ion, and oxygen gains 2 electrons, becoming a 2- ion. Another example you will need to know for your exam is calcium chloride. In this case, calcium loses 2 electrons, giving 1 each to 2 chlorine atoms, forming a calcium 2+ ion and 2 negative chlorine ions. Now, let's have a quick recap. For the following sentences, select the right answer to fill the gap. Now you've got ionic bonding covered, let's move on to covalent bonding. In a covalent bond, instead of transferring electrons, atoms share electrons. Think of it like this. Simon has taken Claire out for ice cream. They both order the chocolate sundae, but there is only one left, and so they decide to share it so that they can both enjoy it. This is what happens with atoms. In a covalent bond, both atoms want to achieve a full outer shell of electrons, so they share electrons with each other in order to make this happen. Here is an example. Oxygen bonds with 2 hydrogen atoms to form a water molecule. The oxygen atom has 6 electrons in its outer shell, but needs 2 more to complete it. Hydrogen atoms have only 1 electron in their outer shell, but would like 2. And so 2 hydrogen atoms join with an oxygen atom so that they can all have full outer shells. Covalent bonds can be represented with dot and cross diagrams. So, for example, in a water molecule, we could use dots to show oxygen's electrons and crosses to show hydrogen's. When drawing a dot and cross diagram, you only need to show the outer shells. As well as dot and cross diagrams, there are 2 other ways to show covalent bonds, like this, using a line to represent the bond, or like this. As well as in water, covalent bonds are also seen in other molecules, such as ammonia, methane, hydrogen, oxygen, and hydrogen chloride. Substances with covalent bonds can either be simple molecules, like oxygen or water, or giant structures, like graphite or diamond. Simple molecular substances contain small molecules with strong covalent bonds that are weakly joined together, meaning they can be easily broken apart, so they have low melting points and low boiling points. In giant covalent structures, many atoms are joined together by strong covalent bonds to form a giant lattice, meaning they have high melting points and high boiling points. Now, Let's recap what we have learned about covalent bonds. Select the right answer to complete the sentences.